Hello students. In the previous class, in the previous lecture, as I told you that in the next class that I will be discussing about regarding the exercise of the chapter 1, and because already the entire chapter discussion has been over. So today I will be discussing the exercise, the question answers of chapter 1. So let's start the discussion of the exercise of chapter 1, states of matter. The exercise is on page number 11 of your book. If you're having the book with you, then you can have a look of the chapter of the exercise, or if you're not having, no problem. The exercise I'm showing it in front of you. Now let's start with the exercise. The first question is define matter. It's a very straightforward question given in your book, probably on the next or the second page of the chapter. What's the definition of matter? And I also previously in the first lecture I told you what is matter. Anything which can be perceived by our senses, which can be touched, felt, or perceived by our senses is called matter. And examples, of course, you have to give examples. I told you in the last two lectures that whenever you will be giving writing definition, examples are must. Very important, giving examples. So matter, as I said, things or substances or anything which can be felt or touched or seen or perceived by our senses is called matter. Example: table, chair, blackboard, Almira road, bricks, whatever gases, whatever you feel like, you can give the examples. Okay. The next question, intermolecular forces of attraction. The next question is define intermolecular forces of attraction. The definition is the attractive force or the force of attraction which exists between the particles or molecules present inside a matter is called intermolecular forces of attraction. I repeat, the force or the attractive force which exists between the particles or molecules of a matter, by which the particles are held together with each other, is called intermolecular force of attraction. Clear? All right. The next question, what are the three states of matter? I don't think this question needs to be addressed. Three states of matter: solid, liquid, gas. Give an example to that: solid, liquid, gas. Define each of them with example. You have to define solid, you have to define liquid as well as gas. Solid, two properties you can write which have proper shape, size, proper volume, and the substance where the molecules are tightly packed is called it's called solid. Examples, you can give it examples, solids of your choice. Liquid, similar to properties you can write. That means substances or matter which are having no proper shape or size, but takes up the shape of the container in which it is kept, and which is able to flow with medium average intermolecular forces of attraction. So, and the particles are not very closely packed. So that's all. And example of liquid: water, kerosene, whatever. You can give as many examples, minimum 2 asked, so 2, 3, your choice. Similarly, you have to define gases. All right. The next, define interconversion of states of matter. Interconversion of states of matter, you have to define this one. And if I'm not wrong, a very clear definition of this has been given in your book, page number 5. If you see your book, page number 5, a clear, very good definition is given in your book: the phenomenon of change of one state of matter into another, and then back to its original state without any change in the chemical composition is called interconversion of states of matter. Interconversion of states of matter. All right. Okay. Of course, this one once again, example must. Example must. You may write solid water, ice, a reversible arrow to liquid water, reversible arrow to gaseous water. That's an example of interconversion of states of matter. What are the two factors responsible for the change of state of matter? Two factors, temperature and pressure. Coming to question number 4, state the main postulates of kinetic theory of matter. Main postulates of the kinetic theory of matter. There are almost 4 or 5 points given in your book, and if you have noted my first lecture, the first lecture of this chapter, over there also I have mentioned the 4 and 5 points regarding the kinetic theory of matter. So kinetic theory of matter, it's clearly given in your book, page number 4, the postulates of kinetic theory of matter, 5 points given. You have to write all the 5. During the exam time, if this sort of question comes, it will depend upon how much marks allotted. If 4 marks allotted, you have to write 4 points. 2 marks allotted, 2 points. 5 marks allotted, 5 points. What happens if? What happens if? That means what will happen? Only you have to write what will happen. If water is kept in a deep freezer, water is kept in a deep freezer, what will happen? Water will solidify itself. Water will form ice or solid water. So what will happen? Water will either get solidified, you can write, or water will form ice. Anyone you can write when it is kept in a deep freezer. And what will happen if water is heated? Water will turn into liquid water, will turn into gaseous water or water vapor. The next question, explain the phenomenon of change of state of water. Explain the phenomenon. The first, what happens if water is kept in a freezer? As I said, water turns into ice or water gets solidified from solid water. This phenomena is known as freezing. This phenomena is known as freezing. So what you have to do, you have to explain, or rather define, what is freezing. So you have to define what is freezing. A clear definition is once again given in your book on page number probably 7 or 8. Okay, you may check it out, page number 7 or 8, probably 8 or 7 maybe. A definition of freezing you have to give. And what about heating? It's boiling. So the phenomena by which water changes, or when water is heated, water gets transformed, or water changes itself into gaseous water or water vapor, and it's the phenomena is called, what it's called? It's called boiling. It's called boiling. So you have to define boiling. Once again, the definition is given in your book. Question number 6. State the law of conservation of mass. A clear definition, once again, the law is given. What the law states, matter or mass can neither be created nor it can be destroyed within a chemical reaction, but it can be transformed from one form to another form. This is the complete law of conservation of mass. So the law of conservation of mass states, what the law states, that matter or mass can neither be created nor it can be destroyed from one form to another form, but it can be transformed from one form to another form within an entire chemical reaction. All right? Okay. It's better if there is an example given in your book. Once again, if it is possible, give an example supporting this law. The next question, what do you observe when barium chloride solution is mixed with sodium sulfate solution? the observation one. Now observation means you will just write what you observe, that means what you see. Okay, along with that, if you want to write the reaction, it's fine, but only the reaction is not at all accepted. I repeat, only the reaction, or if you write what forms, that means if you write barium sulfate and sodium chloride form, that's not the observation. That is not at all the observation. So observation means what you can see, what you can feel, what you can hear, anything. So those are called the observations. So observation, when barium chloride solution is mixed with sodium sulfate solution, what do you observe? Just write the observation. A white precipitate forms within the solution. That's all. A white precipitate forms within the solution mixture. And along with that, if you want to give the reaction, you're most welcome. Coming to give reasons, a gas can fill a whole vessel in which it is enclosed. The reason is, since gas are having the maximum intermolecular space, so it can move from one point to another point, and hence when it's kept inside a vessel, it takes up the entire space, and thus it can fill the whole vessel when enclosed. Okay. Solids cannot be compressed. For compression, the reason is, for compressing solid or anything, intermolecular space or interparticle space availability is very important. Now, if the things which I want to compress, if there is no space, where will I compress? In solids, no minimum intermolecular space is available, and hence solids cannot be compressed. Liquids can flow. Once again, why liquids can flow? Intermolecular space or interparticle space, availability of that. So the availability of interparticle space or intermolecular space with average interparticle or intermolecular force of attraction existing between the particles of the molecules, minimum intermolecular or average intermolecular or interparticle forces of attraction, average intermolecular space, and thus that feature allows liquids to flow. When magnesium is burnt in air, there is an increase in mass after the reaction. Of course, magnesium burning in air means reaction with oxygen. So when magnesium is metal, so it's an only metal. When it burns in air, that means it reacts with, burning in air means it reacts with oxygen, and an addition comes, but that means oxygen gets added up. Oxygen gets added up to metallic magnesium, and thus the mass of magnesium increases. That means by the formation of magnesium oxide. Coming to the next question, fill in the blanks. The change of solid into a liquid is called, what it's called? Solid into a liquid is called melting. The process in which a solid directly changes into a gas, it's called sublimation. Solid to gas directly. A change of water vapor into water is called water vapor into water. That means gaseous state to the liquid state. So what is called? Condensation, of course. The temperature at which a liquid starts changing into its vapor state, it's called temperature. Be careful, that word temperature is there. So the temperature is called boiling point. The next question, question number 9. Give 2 examples for each of the following. The substances which sublime, naphthalene, camphor. The substances which do not change their state on heating. What's that? Heating. Give oxygen, hydrogen, nitrogen. If we heat gas, gaseous substances, will it change its state after heating? Solids can change their state into liquid, into gas. Liquids can change their form into the gaseous. Solids can change their state by heating into the gaseous. The final one is heating. If we heat gases, so the final one is heating. Now, if we heat gases directly, will they change their state? Of course not. So, oxygen, nitrogen, hydrogen, your choice. You can heat and they will not change their state. Define diffusion. Define diffusion. Now, once again, diffusion, a very clear definition is given in your book on page number 4. The intermixing of two or more substances due to the motion of their particles in order to get a uniform mixture is called diffusion. Page number 4, a clear definition is given in your book. Brownian motion, the random, haphazard, zigzag motion of suspended molecules and particles within a fluid. It's called a Brownian motion. Okay. Coming to next, question number 11. Sodium chloride is added to a definite volume of water and stirred well. A solution is formed, but there is no increase in the level of water. Why? Now, for increase in the leveling of water, that means a substance has to replace a certain volume which water has occupied within the container in which water has been kept. Now, if that substance, additional substance, do not take up that volume, or do not replace water by taking up the volume which water has used up, or rather water has taken up, definitely water will not rise. So what happens over here is, this sodium chloride crystals, when it is added inside water and stirred, it breaks down and the particles become so small that it takes up the intermolecular space of water. What it does, it takes up the intermolecular space of water, and thus, since it is taking up the intermolecular space without replacing or displacing the volume taken up by the water inside the container, hence the water level does not rise or increase. The next question, question number 12. What do you observe when a gas jar which appears empty is inverted over a gas jar containing bromine vapors? Name the phenomenon. Simply, you just give the observation. Once again, I repeat, when the question is about observation, we'll only give observation. So the observation is, bromine is a reddish brown gas. And what's the observation? Observation is, the reddish brown gas takes up, or the empty vessel, the reddish brown gas starts moving from the lower jar to the upper jar, and after a certain point of time we see a uniform mixture of a reddish brown gas in both the jars or the vessels. Name the phenomenon. This phenomenon is called diffusion. Why can a piece of chalk be broken easily into smaller pieces while a coal piece cannot be broken easily? Now, if you notice, coal and chalk are both solids, but the question is, coal and chalk both are solids, but still chalk can be easily broken, can easily break chalk, but not easily coal. Why? The simple answer is, coal, it depends, breaking of any substance depends on the intermolecular forces of attraction. If the intermolecular force of attraction is very high, strong intermolecular forces of attraction, that means the particles or the molecules which are making up the substance is being held together by strong forces of intermolecular interparticle attraction. Okay? And since it is held up by strong intermolecular interparticle attraction, thus strong force is required, or strong energy is required to break that bond, or to break that power, rather force, to overcome that force. Chalk is held together. Chalk and coal differs on this point. Coal is having high intermolecular forces of attraction. The molecules of coal are held by high intermolecular forces of attraction, and chalk is not held by high intermolecular forces of attraction. And thus, chalk can be easily broken, but not coal. So that's all with the exercise. Only 13 questions and one exercise. So that's all with the exercise, and this completes the chapter 1 of class 8. Chapter 1 is being completed. Any other queries if you're having, you can contact anyone of your choice, any other teachers you feel that you are free to contact. And I repeat, I want to tell you something, that is, do write these questions down in your exercise books if you're having, or copies if you're having. But if you're having any queries, you can ask those queries to to the teacher you're comfortable with, but right now do not submit your exercise books. That means do not take photocopies photocopies of the work you have done. Just write it down in your copies or exercise books. Keep the work updated. When the school will reopen, we will collect the copies and check it. All right, but till now there is no point of submitting the scanned pages of what you are doing. 1 or 2 answers if you want to submit, you can submit it, otherwise not required right now. The only point what you are going to do is write it down in your copies and wait until the school opens. All right, another thing I want to tell you, I discussed the questions, so all the questions with you, but along with that there are certain questions. For example, question number 6b, question number 7, question number 10b, 11, 12, 13. These questions you will be provided with solved papers. That solved papers means I have personally solved these questions for you, and you will be provided with these with the answers to these questions from where you will be able to understand that how to write a question, how to approach an answer, what's the method of writing an answer precisely and being compact with all the points given. All right, so that's all for this chapter. Thank you, and stay at home, stay safe, take very good care of yourself and your family members. Thank you.